Let's revisit the bag of words representation. So bag of words representation converts each email to a vector representation, which is then accepted as an input by the multinomial knife base. Generation of feature vectors through the bag of words representation help us actually giving that input to the multinomial knife base, and as a result it generates a vocabulary of tokens which is used throughout the collection of documents. So we have a vocabulary that is then used in all the documents to make them consistent, and then this vectorized messages are input to the multinomial knife base. The conclusion of this case study, although we have the 95.6% results, which are 7% better than the local sensitive hash, but this spam detection is not as real as simple we have made in this case study. The reason is that the attack vectors are different for spam messages. So for instance, some spam messages rely heavily on tempting the reader to click links. So they are not textual messages. They just have, for example, one or two links or one word, and then there is a link actually. So now the email content body thus might not contain as much incriminating text as other kind of spam. And other kind of spam might just rely on images and does not rely on text at all. So that was a kind of filter, or that was the kind of method that we have applied on the textual messages only. We should have actually multiple email filters that are using different techniques. So for example, we can have the spam filters for the textual messages, we have the spam filters for the click only messages, and then we can have spam for images as well. So that is actually, we can have a layered approach where we have multiple machine learning methods are working with each other to produce a combined output. That's all from this case study, and now just let's take a look at the implementation of this case study.